Welcome back, Pre-Calc. Hope y'all are well. Today we are going to solve systems using matrices. So you've solved systems before. Hopefully we can streamline this a little bit for you. If you've got an 84, a TI 84, definitely pull that out. I'll also show you how to do this on Desmos. So I've got the checklist on the screen. You know what to do from here. All right, so you do not need to do anything yet, but just kind of as a warm-up, if I wanted to solve this system of linear equations, which of these operations down here, if any, would I be allowed to do, and which, if any, would be illegal? So I'm forced pause on the screen, read through my three options here, and decide which are allowed and which are not. All right, so can I multiply or divide both sides of an equation by any real number? This is kind of the tricky one, or kind of Whoa. I can multiply both, and we always say if you do one thing to one side, you have to do the same thing to the other side, right? This is true, except there is a little trick here. Like, I can take both sides of the equation and multiply by 2, right? Or -2. Now, what I can't do is multiply both sides by 0, because then I just basically lose all my information. I just get 0 equals 0, which would imply an infinite number of solutions, which is not necessarily true. So this is fine as long as I make this caveat. If I can multiply or divide both sides of an equations by any non-zero real number, right? All right, can I add and subtract the two rows? Absolutely, that's typically what we use for elimination. And can I switch the order of the rows? Totally, right? Doesn't change anything. So these are all allowable as long as I'm using non-zero real numbers. First pause on the screen, can you go ahead and write this system of equations for me in your notes? All right, so you know how to solve the system of equations like this from Algebra 2. Again, what we're going to do today is kind of streamline our process using matrices. So what we're going to do is make a column for our x's, a column for our y's, and then this is called an augmented matrix. You're going to do kind of a dotted line here, and this, I'm going to put C, this is going to be our constants, okay? So I'm going to make a column for x, so I've got 2x here and 1x here. So I'm going to go 2 and 1. Now grab your coefficients on your y's. That's -3 and 4, and then your constants are 7 and -2 respectively, okay? So a rectangular array of numbers like this one is called a matrix. The plural is matrices. The order of a matrix is the number of rows times or by the number of columns. So this matrix has 2 rows and 3 columns. So it's a 2 by 3, which we looked at last time. The difference here is this is called augmented. So you have this kind of dotted line to show where your constants start. So what I'm going to do is I'm going to take that system, change it to an augmented matrix, but basically I'm going to be doing the same algebra that I was doing earlier. So earlier we said I'm allowed to interchange any two equations, right? It doesn't matter which is on top or which is on bottom. Same thing for my rows. I could switch which is on top and which is on bottom anytime I want. I can multiply both sides of one equation by a non-zero constant, meaning I can multiply each entry in a row, because each row represents one equation from the system, right? I can add a non-zero multiple of one equation to another, so the row equivalent operation is I can add a non-zero multiple of one row to another, all right? So let's take a look and see if we can do what we did with systems, but kind of streamline it and make it into matrix. Okay, so what I'm going to do is I'm going to apply those row operations until I can get my matrix to look like the one that I have here. So I'm going to, again, let's say this, I'm going to have 3 variables, okay? So x, y, because if you have 2, typically we can figure that out using good old algebra, elimination, substitution. It's when you get more than 2 that matrices are really come in handy. So I've got my x column, my y column, my z column, and then my constants, okay? So my goal is to get zeros kind of in the lower triangular here, ones in the major diagonal, and then everything else would just be constants, okay? Because then this top row will represent 1x plus a, which is going to be some number, y, plus bz equals c. The second row is going to represent 0x, I can leave that off, plus 1y, plus dz equals e. And the last row is going to represent 0x plus 0y plus 1z equals f. Well, if I know what z is, then I can back substitute and put it in here, which will allow me to find y. And once I've got y and z, now I can find x. Okay, so that's going to be our strategy, is to get my matrix into this format. It's called row echelon form. First pause on the screen, go ahead and copy the system that I have. Okay, now remember, we're first going to make this into a matrix, so let's do that. Let's go. 1, just grab your coefficients, 1, negative 2, 3, 4. Let's go ahead and do our augmentation here. And then 3, 1, negative 1, 0, 2, 3, negative 5, 1. Okay, so this is my augmented matrix to represent the system I started with. My goal is going to be to mess with this enough to get it to look like this matrix here. Again, you've got zeros in your lower triangular, ones in your major diagonal, constants everywhere else. Okay, so now that we know what our goal is, we're going to clear this for now. Let's work with it. All right, so again, let's first make an augmented matrix to represent this system. So I'm going to have a 3 by 4. So grab your coefficients from the first equation. So that's going to be 1, negative 2, 3, negative 4. And then the second row is going to be 3, 1, negative 1, 0. And then again, just grab the coefficients. It's all in order for us. So 2, 3, negative 5, 1. And I'm just going to make, again, my augmentation here. Okay, so if I come back, my goal is to get what in that first row? We're going to work row by row, okay? So first we want to get row 1. So the only thing I need for row 1 is a 1 in the first entry, and then constants everywhere else. Well, lucky us, that part is done, okay? So let's focus on row 2 next. I want a 0 in the first column, second row, okay? So I need to transform this to be a 0 using those operations we talked about, okay? So this is one I kind of like to work with that. What I'm going to do is I'm going to transform row 2 now. So I'm going to say, I do like to do this, my new row 2. And what I'm going to do is I'm going to take my old row 2, and then I'm going to multiply every entry, because what I do to one side I have to do to the other, right? Every entry in row 1 by negative 3. Because what's that going to make this term? It's going to make this a negative 3. And what's negative 3 plus row 2 is positive 3? 0, which is what we want, right? So I'm going to take row 2 and add a negative 3 row 1 to that, okay? And actually let me color code here. So negative 3 row 1. What I'm going to do is just for our reference, I'm going to write negative 3 times row 1 up here, okay? So I'm just going to take row 1, multiply negative 3 to every entry. So 1 times negative 3 is negative 3, negative 2 times negative 3 is positive 6, negative 3 times 3 is negative 9, and negative 4 times negative 3 is positive 12. Okie doke? All right, so here's what we're going to do. Come back here. We are keeping row 1, right? We like row 1. We don't want to change row 1. What we're changing is row 2. So my new row 2 is going to be my old row 2, this row, plus the red row I just made for reference, okay? So negative 3 plus 3 is 0. Hey, that's what we want, right? 6 plus 1 is 7. Negative 9 plus negative 1 is negative 10. 12 plus 0 is 12. And right now I'm keeping row 3. I'm not ready to mess with row 3 quite yet. Okay, so we've checked off one more thing from our list, right? We've got a 0 here. The next thing I need, and the only other thing I need for row 2 is a 1 in the next entry. Okay, so I want to make the 7 a 1. Well, whenever You've already got your 0, so I don't really want to add 2 rows together because I don't want to mess up that work I just did to get this entry to be a 0. So whenever you want a 1, a really good trick is just multiply that whole row by this number, right? If I multiply this whole row, by the reciprocal, divide by 7, multiply by 1/7, it doesn't change the 0. It makes this a 1, and that's all I need, right? So here's what I'm going to do. Keeping row 1, keeping row 3 for now. My new row 2 is going to be 1/7 times my old row 2. Let's see if this will work for us, okay? So come over here, keeping row 1, 1, -2, 3, -4. Now I'm changing row 2. I'm just multiplying everything by 1/7. The reason I'm doing that, again, is because 0 stays, so that's good news. 7 times 1/7 is 1. That's exactly what I want. Then I've got -10/7 and +12/7. Okay, and I'm just keeping row 3. 2, 3, -5, 1. Okay, we're done with row 2 because we've got 0 and 1. Okay, now row 3, I want 0, 0, 1. Take a look over here, all right? We want 0, 0, 1 in row 3. All right. So when I want a 0, I would like to take my old row 3 typically plus some multiple of another row, which is going to need to be row 1 because I've got this 0, which is a little bit troublesome for row 2. There's not much I can do with that. It's just going to stay 0 if I multiply by something, right? So here's what we're going to do, very similar to what we did up here. My new row 3, and hang tight with me, I know it feels like a lot, just hang on. My new row 3 is going to be my old row 3, and then I'm going to subtract 2 row 1, okay? So I'm going to take row 1, multiply by -2. So let's do that for reference, -2. If I take this times -2, that's +4. 3 times -2 is -6, and -4 times -2 is +8, okay? All right, so for this next iteration, we're keeping row 1, 1, -2, 3, goodness. 1, -2, 3, -4. We are keeping row 2, 0, 1, -10/7, +12/7. Now, my new row 3. I'm taking my old row 3 plus the red. Okay, so -2 plus 2 is 0. We like that. 4 plus 3 is 7. -6 plus -5 is -11. And 8 plus 1 is 9. Okay, the next thing I want is a 0 instead of that 7. Now is when I want to kind of look at combining row 2 and row 3. It wouldn't do me any good to add in a multiple of row 1 because then I'll mess up the 0, right? I want to keep the 0, so I'm going to look at combining row 2. Here's what I'm going to do. My new row 3 is going to be my old row 3, and then what would I need to multiply this term by to get this plus this to be 0? I need to multiply by -7, right? So I'm going to add -7 row 2. Again, I'm going to write it up top for reference. So I'm going to take row 2, multiply by -7. So 0 times -7 is 0. 1 times -7 is -7. -10/7 times -7 is +10. And -12/7 times -7 is -12. Okay, let's write our next iteration. So keeping row 1, keeping row 2, now for row 3, I'm going to add the red to my old row 3. Okay, so 0 plus 0 is 0. -7 plus 7 is 0. 10 plus -11 is -1, and -12 plus 9 is -3. Okay, all right, we are almost there. That last one needs to be a 1. Well, remember what we did last time, we just multiplied by the reciprocal. The reciprocal of -1 is -1. So all I'm going to do, I'm not going to bother writing all that again. Let's just flip the signs. Multiply everything by -1, keeps this a 0, 0. This becomes a +1. This becomes a +3. Okay. Now let's write what we just got. So let's convert our rows back into equations, okay? So if I take this string for row, that top row, that is equivalent to x minus 2y plus 3z equals -4, which is what I started with up here. Let's keep going here. The second row, I have 0x, I don't have to write that, plus 1y minus 10/7 z equals 12/7. Okay, and then the last row, here's the good stuff. 0x plus 0y plus 1z equals 3. There's z. Now let's back substitute to get my y. Okay, so I've got y minus 10/7 z, which is 3, equals 12/7. So y is equal, let's see, this is 30/7, right? So y is 12/7 plus 30/7, which is 42/7, which is 6, right? And then finally I can come find x, okay? So x, let's bring it over here. Running out of space. So I have x minus 2 times y, which is 6, plus 3 times z, which was 3, equals -4. So I've got x, this is -12, this is +9, -12 plus 9 is -3. So if I add 3 to both sides, I get that x equals -1, okay? So final answer is this ordered triple, -1, comma, 6, comma, 3, x, y, z. We did it. And this is where I give a lecture of when I was your age, I had to do all these by hand. We're not going to make you do them all by hand, but I want you to see what the calculator is doing so it's not complete magic. Let's show you how to do it on the calculator. Okie doke. So, we did row echelon. We got into row echelon form. An even better form, do you agree, would be this? This is called reduced row echelon form because look, this row would be 1x plus 0y plus 0z equals a. So this just tells me x equals a. This row tells me that y equals b. And this row tells me that z equals c, right? So this is an even better form. It's just it took a ton of work to just get it into row echelon form. Getting into reduced row echelon form would be even more work by hand. But if we're doing it with the calculator, we may as well ask the calculator to get it all the way into this form. To get it into this form, you are using what's called Gauss-Jordan elimination, okay? So let me show you the steps. All right, so grab your graphing calculator if you've got one, and let's talk through this one once more. So you are going to go to your matrix command. See this matrix blue? So I'm going to go second matrix right here. Then you're going to hover over to math. Then I'm going to choose RREF for reduced row echelon form. It's actually fastest if you scroll up. And it is option B. Okay, so I'm going to go RREF. Then I need to type in my matrix. So go alpha F3. Your matrix submenu is in F3, so alpha zoom. And now I created a 3x4, okay? So make sure you've got 3 rows, 4 columns. And then we're going to hit OK. And then we're just going to enter our matrix. So I had 1, -2, I'm just hitting my right arrow each time, 3, -4. And then my second row was 3, 1, -1, 0. And then my third row was 2, 3, -5, 1. Okay, so we're going to take reduced row echelon form of that matrix, hit enter. Look at your last column there, -1, 6, 3. Thank you, calculator. So that top row is saying x equals -1, the middle row says y equals 6, and the bottom row says z equals 3, which is exactly what we got with all that work, and the calculator did it much faster for us. All right, let me show you how to do it on Desmos if you don't have an 84. All right, so this link should be up for you on Canvas. This is Desmos' matrix calculator. So I'm going to start by doing a new matrix. Remember, ours was a 3 by 4. So we're going to start there, and let's go ahead and type everything in. All right, so I have typed this in. I'm going to hit enter, so I've got my matrix A there. And then here's RREF, so I'm going to take reduced row echelon form of matrix A, and here it is, instantaneously, right? Here's X, Y, Z. All right, so here are the calculator commands. I'm going to force a pause on your screen if you want them. Hit continue when you're ready. All right, so try example 3 with a calculator now, either on the Desmos matrix calculator or your 84. Hit continue when you've got it into reduced row echelon form. All right, here is what we should have gotten. Reduced row echelon form of this matrix yields this. So let's grab now each row and interpret it. So the top row is 1x plus 0y plus 0z equals 0, right? So this says x equals 0. The middle row says y plus z equals 0. But what does that bottom row say? 0 equals 1, right? Because here's my augmentation. Is this a true statement? This is not a true statement, so this is no solution, right? As soon as you get a false statement, there's no solution, and we're done. All right, try this one, hit continue when you're ready to continue. Okay, so hopefully we got this. Now let's rewrite our matrix as equations, keeping in mind that our variables are now p, q, and r. Okay, so my first row is 1p plus 0q minus 1r equals -2. The second row is 0p plus 1q plus 2r equals 3. What does the bottom row say? 0 equals 0. Is this sometimes true, always true, or never true? This is always true, meaning there are infinitely many solutions. Now, even though there are infinitely many solutions, it doesn't mean just that every single possible ordered triple is an answer. They still take a specific form. So we go p, comma, q, comma, r, right? Take a look at the two equations that do have variables in them. So the bottom row just tells me there's infinitely many. Look at these two. What variable is in both equations? R is in both equations, okay? So what I'm going to do is I'm going to keep R as R, and then I want to solve for P and Q in terms of R. Here's what I mean. Take that top equation and solve for P for me. So that top equation, if I get P by itself, P is equal to R minus 2, right? So for P, I'm going to have that as R minus 2. All right, now let's do the same thing for Q. So take that middle equation and get Q by itself. So I would subtract 2R. So Q equals like -2R plus 3 or 3 minus 2R, either way. So for Q, I have 3 minus 2R, and R is just R, okay? So now, yes, even though there's infinitely many solutions, I've got a format. For example, if R is 0, one particular solution is -2, 3, 0, okay? I can't just say like 1, 1, 1 is a solution and 2, 2, 2 is a solution. They take a specific form and they all follow this format. So now I can pick a value for R and I know what P and Q are in this case. All right, last example, we're going to set up an augmented matrix that would yield A, B, and C, and then we are going to determine f of x such that f contains these 3 points, okay? So remember, f of x is just a fancy term for y, right? So in other words, when I plug -1 in for x, I should get 3 out for y. So let's make an augmented matrix to represent this first. So what I'm going to do is I'm going to plug in -1 for x. So if I plug in -1 for x, that is going to give me a times -1 squared, so that'll be a, plus b times -1, so that'll be minus b, plus c, and that equals y, which is 3. Okay, let's do the same thing for the point 1, -3. So now I'm going to plug in +1 for all my x's. So a times 1 squared is just a, plus b times 1 is just plus b, and then I've got plus c, and that is equal to -3. All right, last one. Now let's plug in 2 for x. So a times 2 squared would be 4a, plus b times 2, so that's the same as 2b, plus c, and that's equal to f of x, or y, which for this particular x is 0. All right, let's turn this into a matrix now, okay? So give me a 3 by 4. So I'm going to have a column for A, a column for B, a column for C, and then I'm going to augment here, okay? So just grab your coefficients again. So this is like 1, -1, 1, and 3. My coefficients here are 1, 1, 1, and then -3. And then 4, 2, 1, 0. All right, so then I went ahead and did reduced row echelon form of that augmented matrix we just wrote. And so this tells me that A is 2, B is -3, and C is -2. And that gives me that function that I was trying to look for. All right, you all, that is it for today. I'll see you next time.